Sure.
Yeah. So now, as I told, like we will be trying to decrypt the gus.ini file, and so let's do that with the Oli debug tool this time. And let's go to the Oli debug. So I have this over here. Yeah. So just click on this exe file, and okay, so just close it and open that as an admin. Yeah. And now just click here and go to the desktop folder and go to this srvcp.exe. Okay, so as I told, that gus.ini file I have already put in the syswow64 folder, and so I'll just confirm that, because this malware will be trying to read that file from that folder itself. So just see syswow64 and gus. Yeah, so this file is there, and now let's kind of open this in debug, Oli debug, and now let's go to that. Okay, so this is the window of the Oli debug, where you see the registry values are again in this part, and this is where the hex dump of the malware is being shown, and this is the stack memory section over here, and this is the code. Okay, so now I will see like, okay, what are the functions that this process is, because I know that gus.ini file will be opened, maybe some will be normally opened from a function called fopen, like which is related to the file open, that's we normally see in a C language and all. So we will normally try to see that, okay, if that function, where that function has been imported, are being called from this malware sample. So to do that, what I will do is actually just a minute. Okay, so I will press Control plus N, and I will get to know all the functions that has been called. So if I go to the F part and we'll try to see fopen, so I'm not seeing that, right? Fopen. So it seems that malware is not trying to open that file. So any suggestions from you guys why I'm not able to see fopen over here? Any guess?
No idea, Pratik.
Okay, so thing is,
No idea.
okay, so the thing is, when I press the Control plus N and try to see the names of the function that has been imported, or the name of the function that has been imported from the Windows API, so what I am seeing that in the names in NTDLL by mistake. That's why I'm not seeing that fopen. So what happened is, when this code is not actually the code of the malware, but it's the code of the anti-DLL file. That is a proprietary window DLL. I can confirm that over here, module main thread module anti-DLL. So I need to make sure that when I'm analyzing the code, it's like when I load the malware, I'm not analyzing by mistake any other DLL file. Okay, so that's how the whole analysis will break. I won't be able to get the required result. I have to confirm that I have tabbed into the correct exe or correct DLL file that I'm importing. So what I will do is, I will go to the view, I'll go to the executable modules, and over here I see this is the exe file that I'm interested in analyzing, and these are the other DLL files, okay, that I'm not interested in analyzing, because these are all the proprietary Windows DLL, most of them. Okay, so I will double click on this, and now if I see, the name of this module has been changed to srvcp.exe. So make sure when you're loading the code that this module is showcasing the name of the exe file and not some other DLL that it's load by mistake. Okay, and now I do Control plus N. Okay, and now I see like a lot of interesting function over here, and now I also see the fopen. You see here, is it visible to all of you?
Yeah, Pragyan.
Okay, so
Yes.
this, yeah, okay, so
Pragyan,
this, yeah.
Again, we have opened svcp.exe. So ideally, we are supposed to see srvcp only. But
Yes.
why are we seeing other DLL files?
Yeah, so those DLL files are actually imported by this function, because this fopen command, suppose I wrote a C program where I'm opening a file. So I will be using the fopen command for that, right? So that fopen command functionality, that code has been written by the Windows guys, okay, in a particular DLL. The name of that DLL is crtdll.dll, okay. So I don't have to invest time actually in writing the code how to open the file from the hard drive. So those all code has been written by the Windows programmer in a DLL file called crtdll.dll, and they have given us an easy function called fopen, where I just give the argument, supply the argument of the file, and then it gives me the content of that file. I don't have to worry about the code that is written in that fopen. Got it?
Yeah, Bracken. But my question is, um, uh, by default, SRVCP is supposed to show us, but we are seeing other DLL files.
Yeah. So
Uh,
that's yeah.
Again,
So yeah. Please tell.
we are locating it again. Since we have loaded this file,
Yeah.
ideally it is the one which is supposed to pop up.
Yeah, so it should pop up first, right? Correct. But yeah, it's kind of a you can tell the functionality of the Oli debug that it is trying to kind of maybe kind of a issues that it is trying to first showcase me the anti-DLL file. Okay. But yeah, but I can do that by going to the view and then go to the executable mode and then select the proper DLL file that I have to kind of analyze. So that's some of the issues, or maybe tell kind of functionality how the Oli debug programmers has done. Okay. But yeah, so we have to do that. And most of the time you will see, like in other debugger also, like Unity debugger, Immunity debugger, or some other debugger, most of the time they load certain other DLLs by mistake. Okay, so we need to make sure that we are viewing the code of exact the exe file that we want to do. So that's something we have to do most of the time manually. Yeah.
Yeah, fine, Bracken.
Okay. And I will also say it's kind of a good exercise for us, because many times what it happened for me also, like I was trying to develop an exploit actually for a converter. And what happened, I missed that property where I have to load the DLL file, load the exe file, and I actually analyzing some other DLL. So that's kind of functionality that kind of, it was good. Like we went through that. So later when we are analyzing the code, we actually first make sure that we are kind of analyzing the correct exe file. And apart from that, normally what happens, sometimes the exe file also kind of has their own malicious DLL file that they try to load. Okay, so using that same interface, going to the view executable and kind of uh, suppose I got some what to say, some malicious DLL that is in some other temp path, not the system32, but in some temp path. So I can again click that and kind of open that and kind of analyze that from this window. Okay. So for now, I will be using this. And now I will be going to the control N, and it should see that fopen has been called. Okay. So now I want to see that there will be different. So suppose I am opening a file. So in a C code, if I'm writing, it won't happen normally that I am trying to open a file at only one location. Maybe there might be different files that I'm trying to open, and the location of those code entry might be in different places. So what I will do is I will see like where are the places in the code where this fopen has been called. Okay. So for that, I will just do a right click and I will click on find references to import. Okay, so luckily there is only one point where this fopen has been called. But normally when you see other malware sample, there will be multiple entries where this function has been called. So now what I will do is I will right click again, and I will go to follow in disassembler. Okay, so now I am in this line where the function has been called, and I will just I'll just try to put a breakpoint over here. Okay. And what I will do now is I will run the malware again. And so what will it will do is like it will stop at this point of time when it try to touch the fopen. Okay, so I will run the code, and it has exited somewhere. So let me run it again. Yeah. So now I am in the breakpoint. Got it. So now I'm in the breakpoint and kind of, and if you see in the stack area, so this is the stack area, and you see over here that call to fopen is about to be happening, and the path, the stack that has been, the memory, the file path has been saved over here. So it's Windows system32.gus.ini file. Okay, so we have stored that in syswow64 folder, but I think because this Oli debug is in the 64-bit mode, and so that's why this malware is trying to read the file from system32 folder. Okay, so and once I click that, what will happen is this function will be called and kind of um, just a minute, I'll just add a breakpoint again over here. And so I mean to say is that fopen is going to be called, and the stack, it is holding the path of the file from which it will be opening to be maybe to read or to write. So the mode is actually to read. You can see from here. So both the arguments. So if you open any file, you normally see you might have all have idea of a C program or any other program. You call the function fopen and you pass two arguments. The first is the name of the file, and second is the mode that you want to, like read mode, write mode, or append mode. So here I can see the file name as well as the mode that the malware is trying to open. Okay, so is that clear? Any questions still now?
No, brother.
Okay, great. So now I will be going to, because this malware is trying to read the gus.ini file from system32 folder. So what I will do is actually I will keep this file in the system32 folder. So Windows syswow64 gus.ini, I'll copy it and I will put this in system32 folder. Continue. Yeah, so now this file is in over here, and I will close this, and now I will run this again. Just a minute. So it seems there is slight problem in running this code. It's not trying, it is not able to access this, because what normally happens is like when this function actually execute successfully, what happens is that what it is the malware is trying to do is it is trying to read the content of this file, and it will try to kind of decrypt that, and then kind of it will kind of store the result in kind of EAX register. So what will happen is kind of
Pragyan,
yeah. Yes, Sandeep.
are we doing this in the VM, or else are you doing it in
No, no,
your
no.
PC?
I'm doing it inside the VM now. Yeah, I'm doing
Okay,
this.
because whatever the file changes and you have copied this gus.ini, so
Okay.
everything is in VM.
Yeah, I'll just make sure that good. Yeah, you told me. Just make sure. So system32 and US. Yeah, it's there. Okay. And
Oh, okay.
yeah.
Fine.
Yeah. So what happened is actually the result is actually whenever you call some function, as I told that when you return from this function, the data is actually saved to the EAX register. So what is happening is actually I'm calling this function and just trying to execute this. Just go 3111. So it's some kind of a loop. It is maybe it is trying to decrypt that. This function is trying to decrypt that. And just give me 1 minute. Just go. Okay. So actually, I am seeing the code. Okay. Actually, I'm seeing the what is it decrypted mode of that, but I'm not able to showcase you that kind of in a good manner. But as you can see, that lot of files, a lot of entries in that has been decrypted. But actually, I was trying to showcase that to you in a good mode. So if I have saved the as gus.ini file when I was doing that in a decrypted mode. And so as you can see, just let me, I'll do that. I'll do this over here. And so you can see that this decrypted format, if you see that is actually over here, and it is trying to decrypt the lines one by one. And just let me do that again. So guys, I will be, I'm facing some difficulty over here. I'm facing some kind of error. Okay. So what I will do is kind of, I will go through this again, maybe again, I will do a fresh analysis of that. I'm facing some error. I think that error to be resolved, I need some more time. Okay. So I'll go through that again. But what will happen is like the result of that will be actually, the decrypted format will be actually returned to the EAX register, which will point to the decrypted data. And this is something that I have captured last time, that when it was decrypted. So as you saw, some of the lines in the first entry were decrypted, but these all things will also be decrypted. And actually, what will happen in the stack, all the decrypted part will be stored, and I was able to copy that one by one. Okay. And this is something that it shows in the decrypted format, that it is actually trying to connect to different IRC channel on port number 6666. It's not just a single one. And then it is trying to connect to that IRC channel with different offensive names, and trying to connect to a different channel with a different username. And then it is the malware author is kind of trying to give the command to that malware, and the malware is actually executing those commands and trying to give the output of that in the same channel. So this activity I will go again just want to make sure that I'm able to resolve that error before starting the class. I was able to do that, but I need some more time over here. Fine. So any questions as of now, till now, from any of you? I know this.
No, Pragyan, everything's clear.
Okay, so I know this activity was not completed fully. I have to showcase that to you in a more readable manner, so that I will do that once I'm able to resolve that error. I don't want to actually invest time right now in that, because that will take me some more time. Okay, maybe in half an hour or something. Okay, so once I did this, once I showcase that in the next code, so that will be actually a basic to conclude that that will be a end to the malware analysis of this sample, that's our vcp.exe. And to conclude that we did a behavioral analysis of this malware. We also did a overview of code analysis of this malware, and to state that why I use the debugger to decrypt that file is because if I do a static code analysis now, what will happen is like I have to review the code one by one and kind of understand the code, where the values are going to, which variable it is going to, what are the any encryption or decryption that is happening. So it will take me a huge amount of time, maybe a month, just to analyze the code and track where all the variables are going to and what the changes that is going to over there. So in the debugger, what is happening is I'm just setting up a breakpoint, and what I'm doing is I'm letting the malware decrypt that for me. And as soon as the decrypted format has been done, I'm just going to the ex register and seeing like the decrypted data. I don't have to invest time now doing a static code analysis and trying to decrypt the file. So that's the benefit that you will get when you use the debugger for any analysis. So it will save you a lot of time to kind of encrypt the thing from your end. Obviously you can do that, but it will take a huge amount of time. So I guess any questions till now from all the activity that we have done till now for this malware sample?
No, Pragyan.
No, Pragyan.
Okay, great. So I hope like till the time like I showcase your tools and all to do the behavior, I hope you are fine with that. And thing is, now when I will be starting with another malware sample, that is brbot.exe. I will be actually not just showcasing the similar tools to do the analysis. We will be using a lot of different tools over there, and kind of like even before we start with the behavioral analysis, we will do a static analysis of the code and try to see like what all what all activities, what are the capabilities of those malware. Okay, so I'm stopping this malware analysis of srvcp.exe now, and right now I'll just check if this malware sample is not running. And just let me see the time. It's 9:49. Okay, so I will now go to the malware.
Pragyan, I have one question here.
Yeah, yes.
Pragyan, for the next class, right? You said you're going to show us the brbot.exe sample. Do
Yeah.
we need to prepare anything in hand, like anything you want us to focus on before we attend that class?
No, actually, thing is like almost 50% of the activity which it will be similar to us. And thing is, in the PDF file, as I told, like I have already mentioned like what all tools I will be using for and analyzing the samples of srvcp and brb board. So that will actually cover both of them. And I will also do analysis on the Linux VM for the malware sample, and that Remnex VM actually has all those tools pre-installed in that, so it won't be there won't be any roadblock to that.
Okay. And for Oli debug tool and all, Pragyan,
Yeah.
can you suggest me some good resources where I can start learning the assembly language stuff, because I'm totally new to this. So any suggestions would help me to make this Oli debug tool easy to me.
Okay.
And
Okay.
like to suggest.
Okay, guys. So yeah, so this is for all of them. Thing is like obviously I will be covering a lot of assembly in much more detail in the part 2 of the course, where I will be investing a lot of time in understanding the assembly language, like what are all the operands, what are the instructions, what those instruction does. But apart from that, if you guys want to kind of prepare yourself a bit ahead, you can, like one of the thing that I read in my college time was there is an assembly language tutorial for Windows and Linux from securititube.com. So that will give you a head start, like how to kind of it's actually 8 years old now. I think more than 8 years old, but it is still like it will give you a heads up, like how the assembly kind of looks like, what are the operations, and kind of how you can like make your own code. Suppose you can write your own code in assembly language directly without writing in a
Uh,
C language.
can you paste it in the chat, Pragya?
Yes, yeah. So yeah. So this is something that you can go for now. And apart from that, we are also planning to kind of make a course, online course that is only specific to assembly language later. That has been planned from our side. And kind of, yeah, and now thing is like, but I will be like, you don't have to worry because I will be covering all those assembly language in much more detail in part 2 of the course. Okay. So I think for the srvcp.exe, you get a lot of good ideas like how to do a basic analysis, how to do a behavioral and code analysis of the tool, and kind of why this analysis is needed, because a lot of IOCs and all we can't just see from a overall forensic activity. We have to do a much more in-depth malware analysis when we see know more of the IOCs, and we also get to know the what to say, the intention of the malware attacker, like what is intention, his intention behind attacking our system with that malware. Okay, so this is what the srvcp module malware that I will end, and now I will go to the uh, brbot.exe. So So this sample I have already shared with you guys, and it's actually contain only the brb.exe. And I think I have 8 minutes. So what I will do is like now, like as I have the timer running for 8 minutes now. So before that, for at the last moment, I'll just maybe stop the analysis for today because it's already been 2 hours now. And we will again start continuing with the analysis of brb.exe in the next class. And for today, I will just start with the BRB board, some basic analysis. So we will start with now. This time we won't start with directly doing the behavioral analysis, but we will also do a static property analysis before even running the code. Neither, nor in the debugger, nor in the actual system itself. Okay, so what happens is like the scenario I will set up for this malware, that we got a how this sample came into being is that the incident responder actually got an alert from some employee that his laptop is actually showcasing slow performance, lot of like there's a lot of CPU spike and all. And when kind of an basic analysis was done, what we found was like a process name as brbot.exe was actually running in the system, and from a system32 folder. Okay, and kind of we have to now analyze like what is the capability of this malware and what are the IOCs we have to create, and kind of again do a enterprise wide hunt where the malware samples are existing. Okay, so before doing any behavioral analysis, it's a good idea actually to kind of start with a static property analysis, and kind of we'll also kind of see like, okay, what is the hash of this exe file and all other details. So what I will do is kind of um, I just want to talk you about the hashes. So what happened, so any idea from both of you guys you have about the hash that you can tell me?
Yeah, Pragyan, there are different kinds of hashing algorithms that can be used to create a hash. For
Yes.
example, MD5, SHA.
Okay. Yeah. uh, am I audible to both of you? Is it fine?
Yeah, again, you are
Okay.
audible to
Yeah,
speak.
yeah. So correct is, yeah, you're correct that there are a lot of there are multiple kind of hashes existing now, MD5, SAR1, SAR256 and all. And like I think 2 or 3 years back, MD5 hash was actually told by legal team not to use because MD5 has lot of kind of what do you say, different files can have different files content can have similar MD5 hash. That was proved practically. That's where MD5 hash is now not much used, but kind of now we stick to SAR1 or SAR256 hashes. And thing is, for the hash, when we calculate the hash of brbot.exe, I just want to tell you that don't just kind of calculate the hash of directly of brbot.exe, because thing is like suppose you get the hash as 1234. Okay, and maybe the malware attacker can again update the malware with some little bit kind of data, and the hash will completely change. So you won't be able to capture the updated malware. So there is a technique by which you can depend on hash, but then also you can actually what to say, uh, get a hold of any malware, updated malware sample, and you can alert someone else like from the same hash that okay, the malware has been updated and the hash has been different. So I will go through that. I will showcase you how to achieve that functionality, that even though the malware attacker has kind of made some changes and you get a different hash, but you can get hold of that okay, this is the same malware sample and that has been slightly updated by the malware writer. Okay, so this is a,
Prajan, sorry to cut you off. Is it
yeah.
okay if I disconnect with the session? I'll catch up on the remaining 5-10 minutes from the recording. I have a meeting to attend and it's about to start.
Yeah. Oh, no problem. Then what I will do is like we'll stop the class for today, and kind of we'll start the face analysis of BRB bot from the next class. Is that fine to both of you?